Welcome to the world of maths.
From class 11. Recall from class 11 that the three-dimensional geometry has x-axis, y-axis and z-axis respectively. If we consider point P in space in relation to origin such that vector OP forms the position vector. So what is a position vector? A position vector is a vector having origin as its initial point and any point P in space as its terminal point. The main keyword to note here is that the origin is its initial point. So vector OP is a position vector respectively. OP is also represented as vector R. We can use any alphabets, but commonly we represent it as vector R. The position vector is represented as vector R, and the magnitude of the position vector is equal to root of x square plus y square plus z square. This magnitude is derived from the distance formula which we learned in 10th standard. How vector OP is equal to magnitude of vector OP is equal to root of x minus 0 the whole square plus y minus 0 the whole square plus z minus 0 the whole square, hence it is equal to root of x square plus y square plus z square respectively. We learned about position vector. Now consider that this position vector OP makes angle alpha with the positive direction of x-axis, beta with the positive direction of y-axis, and gamma with the positive direction of z-axis. This angles alpha, beta, gamma made with the positive direction of x-axis, y-axis and z-axis respectively are called direction angles. And cosines, if we take the cosines of these angles, that is cos alpha, cos beta, cos gamma, are called the direction cosines. This direction cosines, that is cos alpha, can also be written as L, cos beta as M, cos gamma as N respectively.
What are direction angles and direction cosines? Direction angles are nothing but what the position vector OP makes with the positive direction of the angle that the position vector OP makes with the positive direction of x-axis alpha, and the angle that the position vector OP makes with the positive direction of y-axis beta, and the angle that the position vector OP makes with the positive direction of z-axis gamma are the direction angles. Now these cosines, that is cos alpha, cos beta, cos gamma, are the direction cosine. So we learned till here. Now we will continue to learn what are direction ratios, which is a very important concept. The position vector OP making with the positive direction of x-axis an angle of alpha. Now if this point P has x coordinate, y coordinate and z coordinate respectively, so this point P is of x length, right? So let us mark here this point as A. So OA is of x length. Now let us join this point A and P. So in triangle OAP, where A makes an angle of 90 degree. In triangle OA and P. Where A makes an angle of 90 degree This is alpha, and this is x length, and this is nothing but vector OP is also vector r. So this magnitude will be magnitude of vector r. So if we take cos alpha, so this is adjacent to alpha, angle alpha, by hypotenuse, and this is hypotenuse opposite to 90-degree angle. So cos alpha is equal to x by magnitude of r, which will be x by r. And let us take this cos alpha is equal to x by r. Let us take this as equation 1. That this position vector OP makes an angle of beta with the positive direction of y-axis. So this coordinates of point P will be x, y, z. So hence P makes an length of y with the y-axis, right? So this is y length. This is of y length. And let us consider this point as B. Let us join PB. The angle that B makes in triangle OBP will be 90 degrees. So cos beta is equal to adjacent. This is adjacent to angle beta, which will be y by hypotenuse. Hypotenuse is opposite to 90 degrees. See? So this is vector r, so magnitude of vector r. So it will be y by r. Let us take this as equation 2. So saw that position vector OP makes an angle of gamma with the positive direction of z-axis, right? So this point P is of x, y, z. It has the coordinates x, y, z. So P makes a length of z with the positive direction of z-axis. Now let us take this point as C. Let us join CP. We know C angle C is of 90 degrees, where angle C is of 90 degrees. This is gamma. So cos gamma will be adjacent. Adjacent is z. See, adjacent of angle gamma, which is z, divided by hypotenuse. Hypotenuse is opposite to 90-degree angle, which is vector r. Vector magnitude of vector r. We should not consider vector r. We should always take the length. For cosines, sine, all the trigonometric, we take the length. We don't take the vector. So z by magnitude of vector r, which can be written as z by r. Let us consider this as equation 3. In 1, 2 and 3 we have cos alpha is equal to x by r, cos beta is equal to y by r, and cos gamma is equal to z by r, which can also be written as L is equal to x by r, m is equal to y by r, and n is equal to z by r. This is n is equal to z by r respectively. Why we are writing cos alpha as L, cos beta as m, cos gamma as n? Because we saw in the previously also, right, that cos alpha can also be represented as L, cos beta as m, cos gamma as n respectively. So L is equal to x by r, m is equal to y by r, and n is equal to z by r respectively. This x, y, z are nothing but the coordinates of point P. So x can be written as LR, y as MR, and z as NR. respectively. The point of doing all the triangles and deriving 1, 2, 3 is to learn about the direction ratios. So, what are direction ratios? Direction ratios in vectors are nothing but the coordinates of the point P. So, this is x is the x, y, z are respectively the direction ratios of vector OP, and this direction ratios can be represented as LR, MR, and NR. How? If we if we cross multiply this R with L, we get X is equal to LR, and similarly Y is equal to MR, and Z is equal to NR respectively. The numbers LR, MR, and NR are proportional to L, M, and N respectively. What are LR, MR, and NR? They are nothing but the direction ratios A, B, and C respectively. And what are L, M, and N? They are nothing but the direction cosines cos alpha, cos beta, and cos gamma respectively. Let me show you how they are proportional. LR by L is equal to MR by M is equal to NR by N. If we cancel L and L, M and M, and N, we get R is equal to R is equal to R. Hence, LR, MR, and NR are proportional to L, M, and N respectively. LR, MR, and NR are the direction ratios, which can also be said as ABC, as ABC are, or LR, MR, NR are the direction ratios of vector OP. Now we are going to learn a very important result, so please make a note of it, which we will be using in the exercises later. That is L square plus M square plus N square is equal to 1. That is cos square alpha plus cos square beta plus cos square gamma is equal to 1. A square plus B square plus C square is not equal to 1. Please remember this. It is not equal to 1. That is, when the squares of direction cosines are added, they give the result as 1. But when the squares of direction ratios are added, they don't give us the result as 1. The proof of this we will be learning in the next lesson, which is a continuation of vectors, that is 3D. Again, I am repeating, the cosines when squared and added, they will give the result as 1. That is L square plus M square plus N square is equal to 1. If you like our channel, please do subscribe and hit the bell button. Thank you.